In this lesson, we're going to talk about how to solve a quadratic equation by the method of completing the square. Here on this slide, I have the procedure or the steps that you're going to follow to complete the square, and I have a little visual of what completing the square actually looks like. Let's go ahead and dive into some problems. Just as a reminder, the purpose of completing the square is to solve a quadratic equation. And the purpose of solving a quadratic equation is to determine where the graph of the quadratic crosses the x-axis. So let's go ahead and read this note here. The note says, always start the process from standard form. So before you begin any problem, you should always put your quadratic equation into standard form, which is ax squared plus bx plus c equals 0. So let's look at this first one. And I also want you to take note that this is a quadratic where the a coefficient equals 1. All right, let's go ahead and start. I'm just going to start by kind of just moving things around a little bit. So I'm going to go ahead and move the right side back over to the left side. So here we go. I'm just going to go ahead and rewrite it as x squared plus 14x plus 40. And that is all going to be equal to 0. All I did there was kind of manipulate that equation around to put it into standard form. All right, now that I'm in standard form, I can go ahead and start the completing the square procedure. Step 1 is to move the c coefficient over to the right-hand side. So I'm going to go ahead and do that. I'm going to go ahead and do that by subtracting 40 from both sides. I'll be left with x squared plus 14x is equal to negative 40. Okay, that's step 1. Now, step 2, what we're going to do is we're going to take a look at the b coefficient. In our case, this is positive 14. And what we're going to do is we're going to take that positive 14 and we're going to take it off to the side and we're going to do a little bit of work. I'm going to take that positive 14 and I'm going to divide it by 2. Dividing it by 2 will give me 7. I'm going to take that result there, that's 7, and I'm going to square it. That will give me 49. 49 is the number that I want to work with. Now, what I want to do with that 49 is I'm actually going to add it to both sides of the equal sign. So let me show you what I mean. I'm going to first go ahead and add it to the left-hand side. So I'm going to go rewrite the problem, and I'm going to add 49. And then on the right-hand side, I'm going to do the exact same thing. I'm going to add 49 to negative 40. Now, let's go ahead and simplify this, or just kind of tighten it up a little bit. You can see the right-hand side can be simplified to 9, so let's just go ahead and do that. X squared plus 14x plus 49 is equal to 9. All right, this is the point at which you want to get to when you're completing the square, because what this does is if you take a look at the left-hand side, every time you do this process, it's going to create a perfect square trinomial. And let me go ahead and just do a little refresher on what a perfect square trinomial is. So looking at this, we can test that it's a perfect square trinomial by taking the square root of the first term. So the square root of x squared would give me x. The square root of the last term, which is 49, which would give us 7. If I multiply those two together, that would give me 7x. Now, if I take that number and now double it, that will give me 14x. And 14x just happens to be that center number. If that is the case, that means that you have a perfect square trinomial. And that's a review from Unit 7. So if you complete the square correctly, it should give you a perfect square trinomial every time. So you shouldn't have to do that little check step that I just did. It'll automatically work every time. All right, because now if we remember this special case, the perfect square trinomial will break into a binomial, two binomials actually, where the square root of the first term, which is x, square root of the last term, which is 7, and this operation in front here of the b coefficient will be my operation. And that will all equal to 9. And that we learned that in Unit 7. That's a special case. Now, we also learned in Unit 9, to eliminate a square, we actually have to take the square root. And if you take the square root of one side, you have to take the square root of the other as well. So that will leave us with x plus 7 is equal to positive or negative 3. I can continue this problem by subtracting 7 from both sides, and that will leave me with two answers, or two roots. X is equal to positive 3 minus 7, which would give us negative 4 as one of my answers. And x is equal to negative 3 minus 7, which is negative 10. So there you have it. Those are your two solutions to your quadratic equation. And again, as a review, what those mean are those are the two places where the graph is going to cross the x-axis. So this is just another way to solve for those numbers. Okay, now let's go ahead and try another one. Let's go ahead and try the second one. And the second one's kind of unique because this one, you can't really see it quite yet, but the coefficient A is going to be greater than 1 in this case. So we're going to have to do an extra step in the process. So first, let's go ahead and put this into standard form. So I'm just going to kind of maneuver things around. So I have 4x squared. I'm going to move the x over, so that's plus 24x. And minus 108 is going to stay on the same side, and that's all going to be equal to 0. Okay, now that I'm in standard form, what I'm going to do is I'm going to move my c over to the right-hand side. So I'm going to go ahead and add 108 to both sides. That's going to leave me with 4x squared plus 24x is equal to 108. Okay, now, in the problem up above, it says that a is greater than 1. In this case, you have to simplify it at this moment in time. And the way that you simplify it is you're going to divide both sides of that equation by that leading a coefficient, which in our case is 4. So we're going to go ahead and simplify that. Now, you'll remember back in Unit 1, we talked about how to simplify this fraction here. So let's go ahead and do that. I'm going to use the little butterfly method that we learned. So 4x squared divided by 4 is going to leave us with x squared. And then positive 24x divided by 4 is going to leave us with positive 6x. And 108 divided by 4 on the other side is going to leave us with 27. So you can see what that did. That eliminated that coefficient in front of the x squared term, which is what we wanted, because now we can continue the process. Okay, so what I'm going to do now is I'm going to take my b coefficient and I'm going to take it off to the side. And this could also be just a mental thing that you do. You don't actually have to write it down, but I'm going to write it down just so that I can show you what to do. I'm going to take positive 6 and I'm going to split it in half. That's going to give me 3. Then I'm going to take that 3 and I'm going to square it, and that's going to give me 9. 9 is the number that I'm going to add to both sides of the equal sign. Okay, so here we go. X squared plus 6x. I'm going to add 9 to the left side, and then I'm going to go ahead and I'm going to add 9 to the right side. All right, let's go ahead and simplify this down just a tiny bit. That's going to leave me with x squared plus 6x plus 9 on the left, and that's going to leave me with 36 on the right-hand side. You can see that on the left, it created a perfect square trinomial, which is what we wanted. So we can automatically break that into two binomials, x plus 3 squared. And that's going to be equal to 36. All right, let's get rid of the square now. We have to take the square root of both sides. And I'm going to go ahead and bring my work right up here. That's going to leave me with x plus 3 is equal to positive or negative 6. I'm going to go ahead and solve the equation by subtracting 3. And I'm going to be left with two answers. X is equal to 6 minus 3, which is 3. That's one of my answers. And then negative 6 minus 3, so x is going to equal negative 9. And so those are my two solutions to my quadratic equation. All right, now those are two examples. I have two more examples for you that are just slightly different. So let's go ahead and take a look at those. All right, in this next example, you can see that I kind of tell you ahead of time that these are going to be non-integer coordinates. So these are going to be where the location where the graph meets the x-axis is not going to be a nice integer. It's going to end up between two integers. So we're going to end up with a simplified radical and decimal answer for this one. So let's go see what it looks like. You can also see that my leading coefficient is 2, so I'm going to have to eliminate that as I work. So let's go ahead. Now, I do want to make a note here. Do you notice that I'm not in standard form technically, but do you see how I have a constant on the left and a constant on the right? I don't have to add 10 to both sides and then move it again over to the right. I can just immediately start by adding 66, and that will bring my the whole value of C over to the right-hand side. Hopefully that makes sense. 2x squared minus 16x is equal to 56. Okay, now let's go ahead and take care of that coefficient out front. I'm going to go ahead and divide both sides by 2. And I'm going to go ahead and do my little butterfly method, and that's going to simplify my expression. So 2x squared over 2 is just going to leave me with x squared. And then be really careful with the negative there. It's negative 16x over 2 is negative 8x. And that's going to be equal to 28. All right, now that you're simplified, let's go ahead and complete the square. I'm going to go ahead and kind of jump off to the other side. I'm going to take negative 8 and I'm going to divide it by 2, and that's going to give me negative 4. And then I'm going to take negative 4 and square it, and that's going to leave me with 16. And 16 is that number that I'm going to add to both sides. So here we go. X squared minus 8x plus 16 is equal to 28 plus 16. Now, I'm going to show you how to kind of do this all in one swoop here, so you don't have to simplify that right-hand side. But if you want to break it up, that's fine. But you can see that this creates a perfect square trinomial. So let's go ahead and immediately break it down. I'm going to have x minus, and that's going to be a 4 squared. And that minus, again, comes from this minus right here in front of the 8. And then I'm just going to go ahead and I'll simplify it here at this point, 44. All right, let's continue doing the square root on both sides. And that's going to leave me with x minus 4 is equal to positive or negative root 44. And you might be thinking, wait, the square root of 44 is an unsimplified radical. And you're exactly right. We actually have to go ahead and simplify that radical. So let's go ahead and do that. I'm going to take positive and negative root 44 and just take it off here to the right-hand side. And let's just go ahead and simplify it. I know that that can break into root 4 and root 11, which will simplify down into 2 root 11. So really, I'm going to go ahead and replace it with 2 root 11 because that's my simplified radical. Okay, so now we have x minus 4 is equal to positive or negative 2 root 11. I'm going to add 4 to both sides. And here's how I'm going to indicate my answer here. I'm going to indicate it like this. X equals, it doesn't matter which one you write first. Technically, I usually like to write the integer first. So I'm going to write 4 plus or minus 2 root 11. And that's essentially your answer. You can actually write it just like that. That is perfectly fine. If you wanted to switch it around, you could write it as x is equal to positive or negative 2 root 11 plus 4. That's perfectly fine as well. The commutative property works perfect in this. Now, if you really wanted to kind of get technical here, you could say what is the decimal point of each of these, and basically it would give you 2 decimals, Let me go ahead and write it here in orange. The positive root, or the plus 2, would give you about 10.6. And then the negative would give you, let's see here, that would give you about negative 2 point, we'll just say 6. So you could get the decimals or you could get the radicals, whatever you'd like. But basically what that's saying is that's where your graph is going to cross the x-axis. Okay, I do have one more example here for you today, and this example is going to be an example of a no solution problem, okay? So we're going to start by putting it in standard form, but again, we're going to end up with a situation like we did before where we can just start by moving that constant over to the right-hand side. It's not going to affect anything. So let's go ahead and subtract 24 from both sides. Okay. When we do that, we are left with x squared minus 2x is equal to negative 21. We do not have a coefficient to eliminate in this one, so we can just go ahead and start the process of completing the square. I'm going to go ahead and take that negative 2 off to the side, and I'm going to cut it in half. And then I'm going to take that negative 1 and square it to give me 1. So 1 is the number that I'm going to add to both sides. So x squared minus 2x plus 1 is equal to negative 21 plus 1. I can go ahead and simplify my perfect square trinomial that I've created. That's going to simplify to x minus 1 squared, and that's going to be equal to negative 20. I'm going to go ahead and take the square root of both sides, and you can see that we're running into a little issue here. X minus 1 is equal to the square root of negative 20, which we know we cannot take the square root of a negative number. And therefore, the problem just kind of comes to a halt here. You can't do that, and therefore, this would be a no solution problem. So there would be no location where the graph would cross the x-axis in this problem here. So you would just write no solution. All right, that brings us to the end of our lesson on completing the square.